Hello everyone, my name is Damien. I lead product at Wherobots. And if there's one thing that I want you to leave with today is to feel a bit more empowered for extracting insights from geospatial data. And what I'm going to talk in more detail about today is specifically extracting insights from satellite imagery. And then by the end of the presentation, we'll give you some time for Q&A. If we run out of time, we have a booth over just under the Hitachi sign, and you can find us over there. So let's go ahead and get started. The need to observe, understand, and create insights from what happens in our physical world has never been higher than it is today. And it's an unfortunate and inconvenient truth that this need will only increase. Let's take Hurricanes Helene and Milton as an example. First is we cannot replace the lives that were lost. I extend my sympathy to you if you were impacted and your family and friends were impacted by these events. The Southeast is moving ahead, and they're replacing the billions of dollars in infrastructure actively at this point in time. And one thing that is available for all of us here is geospatial data. And what geospatial data can provide is a path forward to be more resilient to such events, and also not just resilient to these types of events, but more resilient to the changes that are happening within our physical world. Because there's trillions of dollars at stake. Let's take a look at Las Vegas. Look around. There's trillions of dollars in just this city alone. And there are businesses across the world, governments, societies that have huge amounts invested that are at the mercy of whatever happens in the physical world. Let's walk through a few examples. Logistics and operations. Companies like Amazon, Uber, JB Hunt, they all have billions of dollars invested in their operations, their supply chains, and they want solutions that are going to help them navigate, things like weather, supply and demand changes, road conditions, construction, etc. All of those types of events are captured by geospatial data. You also have insurance companies, and they're finding it increasingly hard to provide competitive insurance coverage because they may lack capabilities that make it easy to continually assess asset risk at a granular level, like a home. You also have banks, real estate companies, and other asset management companies that have trillions of dollars invested in physical things around us, including land. And of course, there's forestry and agriculture, and these companies are struggling to create better solutions that adapt to what's happening in our physical world. Then there's like the mobility, automotive space. Those companies are they're building solutions actively to help us navigate the constant dynamics of our physical world. And finally, there's local and national governments. And they're investing in better land management techniques and trying to figure out how to build better civilizations. But all of these industries, and there's others, can find the solutions that they need in geospatial data. But as you're here today probably to learn, I'm on stage to tell you that it's not easy. But if it was easy, I wouldn't be here. And so there is a path forward for how to extract insights easily from geospatial data. And that's what you see. First is, let's start with the data itself. There's petabytes of data available at your fingertips. And a lot of this is available today on the AWS Data Exchange. It's coming from satellites to drones, GPS devices, the vehicles around you, and then there's many different data providers that are offering curated forms of this data to make it easy for you to create the solution you need. This is very large-scale data. This is not small-scale data, and which means that the data itself, it's special. It's the way that it is stored and the way that it is structured is not familiar to most computation engines that you would find in the cloud today, because they're generally better suited for processing internet data, not data about our physical world. And so when you try to process this information in a cloud analytics engine, big data engine, you'll find that first is performance is disappointing. These solutions they're not designed to process that type of data, and so that they struggle to chug through it and create the solution you need. They may also struggle to scale. I mentioned that the geospatial data from satellites and others, or like that data is very, very large scale, and so you need a solution that's going to work from very small scale all the way up to planetary scale data. Second is when you look at these solutions, that the support that they're providing you to build the solutions you need is missing. And this includes like the unique spatial operations that your teams need to do the work to create the solutions, et cetera. And then finally, some of them will also may require you to move the data in, use proprietary formats, and all of this creates challenges that inhibit your ability to build the solutions you need to drive forward. And if you look at the space, like the geospatial space today, if your teams are trying to build a solution, they'll probably tell you it's kind of like a Frankenstein architecture. And it really is, and it all starts with the fact that compute in the cloud, the compute solutions you find in the cloud were not built for spatial data. So you might have them augmenting those solutions with different tools, different libraries, different visualization layers. All of this work and overhead adds on to the cost of building the solution you need. It also puts geospatial data solutions out of reach for most companies unless they have the time, talent, and money to invest. Mo and Gia are our co-founders of Wherobots, and they saw this problem many years ago, and Mo and Gia met at Arizona State University, and their research was founded on the back of this belief that geospatial data can have a huge impact to the world, but they also saw that these challenges that I just described. The technology just wasn't there to make it possible for you to make sense of this data and also put it to work. And so the first thing that they did is they were experimenting with Spark. Spark was a big data architecture, but it wasn't well suited to process geospatial data. So they invented and brought the Apache Sedona project to life. It is an open source library that makes Spark suitable for geospatial workloads. It's also enabling Flink, and it's also used with Snowflake as well. And it's taken off. It was a big surprise to the team, and this is why Wherobots exists today. It provides hundreds of functions out of the box that make geospatial data easy to process on these engines. And it's very popular, and it's also supported. As you can see here, the growth is increasing every month. We're getting more and more downloads. And the companies that are picking up Apache Sedona are very noteworthy. Amazon, Uber. Amazon's using it for last mile delivery. They had a presentation this week, and they talked about how they're deploying Apache Sedona. Uber, Mercedes-Benz, Land O'Lakes, Swiss Re. There's many others that are out there taking advantage of Apache Sedona and leveraging it mostly for Spark workloads and also in Snowflake to propel their solutions forward. So let's talk a little bit more about Wherobots. So Wherobots is a company, and we're on a mission to make geospatial data easy. I mean, that's ultimately the big problem we see in the market today is geospatial data is hard, and it's hard for companies to build solutions on. And so what we've done is we've built a product and a team really focused on making it easy for our customers. And so first, I mentioned speed, scale, and performance. Those are all like core characteristics of maybe air, food, and water characteristics that you need. we deliver spatial computation up to 20x, sometimes more than 20x higher performance than you'll find on other managed Spark solutions. We can share this data with you on a benchmark and walk you through it and how to test that for yourselves. But one thing you'll notice is just the pure speed and performance of Wherobots. And what we've done is we've leveraged our research and our expertise in spatial workloads to build the computation engine, optimize it for spatial. So it's not just an off-the-shelf engine and we do the Frankenstein for you. It's literally an engine that's built for these workloads. Developers, this is customers telling us this, they love the fact that they can work with different data types. They can work with geospatial, like the raster data and vector data, all in a single solution. It's compatible with Sedona, and it's also serverless and cloud native. All right, quickly I'm going to walk through the product architecture, how this all works. We're built on the open data architecture. So at the bottom we support Iceberg, Parquet, your data in your S3 bucket. We also integrate with different data stores as well to make it easy for you to process that data in Wherobots. Second is at the heart of this all is Wherobots DB. That's our compute engine. WherobotsAI is our product line that packages has a couple of different machine learning features, including raster inference, which I'll talk about in a second, that makes spatial data solutions easier to build. And then on top of this all, you have these interfaces that make it easy to build the solutions you need, and then also take them into production, because we know that jobs are, those are the automated workflows that customers need to continually churn out these insights at scale. And so we have an integration with Airflow so that you can quickly and easily orchestrate the jobs on Wherobots. All right, let's go into rasters. So a raster is a form of an image, and each pixel in a raster image coming from a satellite is a form of information. That could be elevation, it could be temperature, it could be light, or excuse me, it could be color, and the pixels are organized by the wavelength that they were captured on by rows and columns. And in a satellite image, there's different bands. So you could have different bands representing different forms of information. There's petabytes of this data available today on the AWS Data Exchange. In others, it's everywhere. But it's very hard to put to work. Most traditionally speaking, most companies have hired analysts to look at this and find insights. That doesn't scale, nor is it cost effective. And so what you see now is people are deploying computer vision models at this problem, but there's still challenges that exist because, and I'll walk you through a few of those first. So one is like the computer vision solutions were not designed for satellite imagery. They were designed for smaller scale problems, and so it requires a lot of expertise to just get these solutions working for you, which also makes it hard. The pipelines themselves are expensive, they don't scale, and which also makes the solutions, puts them out of reach. And then finally, the results that you get from, say, like a machine learning model, they're not just usable out of the box. You got to be able to do something with those results ideally in the same environment. And so that's what we do with WherobotsAI Raster Inference, is we have, it's fully managed. Just think about it as a SaaS offering where you pick the model you want to run. We have hosted models. You can also bring in your own model. And it's we've built it and designed it from the ground up to be optimized for these large-scale satellite imagery workloads. It's so that you get a bit like the best price performance and scale in an easy-to-use solution, so that your developers, your team, can just work with those insights, efficiently and effectively. So here's a bit on how it works. You take there's imagery here is let's say this is in the cloud, like on AWS. You actually don't need to migrate the data in. We just reference that imagery with Wherobots, and your developers just start working with it in SQL or Python. The different types of operations, for example, you can segment, classify, detect features of interest easily and quickly, and then you have the results from those models that are ready to go in Wherobots, and you can start to conflate them across different types of geospatial data that you might have. And what I think the most valuable part of this is the developer productivity at the end of the day. What developers get from this is they don't need to worry about machine learning expertise, they don't need to worry about inference, it's all done for them. And then at the end of the day, they get the insights that they need from the imagery, and they can start to conflate those insights in the same platform with other data sets, first party, could be open data, whatever it might be, to build the solution that's going to take their business forward. Getting started is really easy. We have some models that are available today. They're hosted. You can select those, deploy them, and then start working with the insights from the imagery that those models support. You can also bring your own model. We're also working on adding additional models to our hosted catalog. Segment anything is one of those models. We're listening to our customers to figure out what other models they want. So if there's a model of interest that you'd like to see, just talk to us and we can get it hosted on Wherobots to make it easy so that you can just work with the results in SQL or Python. Last week, we announced our Series A, and we also announced our availability on the AWS Marketplace. You can get started for free on our Pro tier, which has most of our capabilities on Wherobots, and it's $400 of free trial credits, and you get started on the Marketplace in a few clicks. So we're really excited about this, and hopefully this accelerates the time to value for you and your use of Wherobots. Our booth is just over here next to the Hitachi sign. It's 1865, and we'd like to talk to you if you have any questions. We've got a couple minutes, so if there's any questions, I can quickly answer them. Thank you.